Magandang araw po sa ating lahat. Mula po rito sa Quarter North District, ako po si Angelo Pineda, nasa ika-11 baitang ng Jadi Region High School. Nakakatulong ang Radyo Eskwela sa aming pag-aaral sa pamamagitan ng pagbibigay kaalaman sa mga nangyayari sa lipunan, na nakakatulong sa maraming asignatura. Dinudugtungan din ito ang kakulangan ng pag-aaral ng mga mag-aaral sa ligtas na pamamaraan, lalo na ngayong panahon ng pandemya. Kaya, lubos kami na nagpapasalamat sa mga bumubuo ng Radyo Eskwela. Sa Radyo Eskwela sa Isabela, patuloy ang edukasyon.
Senior High School On-Air Academy. Unstoppable! Delivering you quality education amidst pandemic.
To defend school opening to October 5.
Unstoppable!
Giving you accessible learning platform anytime, anywhere.
Ang klase, whatever form it is.
Comprehensible!
Buckle up and get yourself ready.
I will repeat, then you will do it later on.
Accurate!
The sphere that includes all living things.
Today, we will be talking about rational functions.
Simplify.
This is Jaw speaking. How may I help you?
This is ZTED School Radio's Senior High School On-Air
On-Air
Academy.
And now, here's your new episode for Numbered Ranks. Your guide for the subject is Statistics and Probability. Numbered Ranks.
Number tricks.
How are you, dear students? I hope you are doing well. It's been a year since the pandemic started. I understand that coping with the academic trend of today creates a big adjustment on your part as we, your teachers, do. In this episode, we shall illustrate the central limit theorem and define the sampling distribution of the sample mean using the central limit theorem. Good day, everyone. I am your radio teacher, Diana Tabak from Etchagüe. Make sure that you focus listening on today's discussion and refrain from doing unnecessary things that might distract your learning. Prepare your pen and paper for your solutions so you can follow the discussion. You should be aware of the instructions for the activities and the quiz. Let's start another statistics journey, guys! In the previous episode, you have learned how to use the normal distribution to gain information about an individual data value obtained from the population. The different properties of the sampling distribution of the mean were also discussed. In this episode, we shall use the sampling distribution of the mean to obtain information about the sample mean. One of the properties of the sampling distribution discussed states that if the population is normally distributed, then the mean is also normally distributed. But what if the population is not normal? Then the central limit theorem comes in. We are going to discuss that just after this break.
Huwag mo nga akong maiiyakan dyan. Hindi ka artista para magdrama-drama ng ganyan. O ano naman ngayon kung binubuli ka sa school? Mahina ka kasi kaya ganyan. Yung mga pinsan mo ang tataas ng marka, tapos ikaw ano? Pumasok ka na doon at mag-aral ka na. Ang napabayaan at napahabang bullying ay maaaring maging sanhi ng depresyon. Ang mga usaping ito ay hindi biro at hindi pawang kaartehan lamang. Isang paalala mula sa kagawaran ng edukasyon at ng himpilang ito.
And we are back. Do you know that the central limit theorem, or CLT, is one of the most important theorems in the practice of statistics? The importance of this theorem has something to do with the distribution of the population. Also, this theorem allows us to make hypotheses about the population. The theorem can also tell us whether a sample possibly belongs to a population by looking at the sampling distribution. Let's start our discussion with the history of the central limit theorem. The initial version of the central limit theorem was coined by Abram de Moivre, a French-born mathematician. In 1733, de Moivre used the normal distribution to find the number of heads resulting from multiple tosses of a coin. The concept was unpopular at the time, and it was forgotten quickly. However, in 1812, the concept was reintroduced by Pierre-Simon Laplace, another famous French mathematician. Laplace reintroduced the normal distribution concept in his work titled Théorie analytique des probabilités, where he attempted to approximate binomial distribution with the normal distribution. The mathematician found that the average of independent random variables, when increased in number, tend to follow a normal distribution. Later, in 1901, the central limit theorem was expanded by Alexander Lyapunov, a Russian mathematician. Lyapunov went a step ahead to define the concept in general terms and how the concept worked mathematically. The characteristic functions that he used to provide the theorem were adopted in modern probability theory. So that's how the central limit theorem started. The central limit theorem, or CLT, is a statistical concept that states that the sample mean distribution of a random variable will assume a near normal or normal distribution if the sample size is large enough. In these terms, the theorem states that the sampling distribution of the mean approaches a normal distribution as the size of the sample increases regardless of the shape of the original population distribution. One of the most important components of the theorem is that the mean of the sample will be the mean of the entire population. If you calculate the mean of multiple samples of the population, add them up, and find their average, the result will be the estimate of the population mean. The same applies when using standard deviation. If you calculate the standard deviation of all the samples in the population, add them up, and find the average, the result will be the standard deviation of the entire population. Now, let's have an example. An investor is interested in estimating the return of ABC stock market index that is comprised of 100,000 stocks. Due to the large size of the index, the investor is unable to analyze each stock independently and instead chooses to use random sampling to get an estimate of the overall return of the index. The investor picks random samples of the stocks, with each sample comprising at least 30 stocks. The samples must be random, and any previously selected samples must be replaced in subsequent samples to avoid bias. If the first sample produces an average return of 7.5%, the next sample may produce an average return of 7.8%. With the nature of randomized sampling, each sample will produce a different result. As you increase the size of the sample size with each sample you pick, the sample means will start forming their own distributions. The distribution of the sample means will move toward normal as the value of n increases. The average return of the stocks in the sample index estimates the return of the whole index of 100,000 stocks, and the average return is normally distributed. An essential component of the central limit theorem is that the average of your sample means will be the population mean. In other words, add up the means from all of your samples, find the average, and that average will be your actual population mean. Similarly, if you find the average of all of the standard deviations in your sample, you'll find the actual standard deviation for your population. It's a pretty useful phenomenon that can help accurately predict characteristics of a population. In order to use sampling distributions for statistical inference, we must learn these three fundamental properties of the sampling distribution of the mean, or SDM, with the assumption of selecting random samples of size n. These properties are: number 1, the mean of the sampling distribution of the sample means is equal to the population mean, or mu. In symbols, mu x bar is equal to mu. Number 2, the variance of the sampling distribution of the sample means, lowercase sigma squared, is equal to the standard deviation of the population divided by the square root of the sample size. In symbol, lowercase sigma squared is equal to lowercase sigma divided by the square root of n. Note also that the central limit theorem is applicable for a sufficiently large sample sizes, or n is greater than or equal to 30. Let's have another example. The record of weights of female population follows normal distribution. Its mean and standard deviation are 65 kilograms and 14 kilograms respectively. If a researcher considers the records of 50 females, then what would be the standard deviation of the chosen sample? I repeat, the record of weights of female population follows normal distribution. Its mean and standard deviation are 65 kilograms and 14 kilograms respectively. If a researcher considers the records of 50 females, then what would be the standard deviation of the chosen sample? From the problem, the given mean of the population is 65 kilograms, or mu equals 65 kilograms. The standard deviation of the population is 14 kilograms and the sample size n is 50. Using the formula for standard deviation, lowercase sigma is equal to lowercase sigma divided by the square root of n. And by substitution, the standard deviation of the chosen sample is 1.97. The next example is a population that has a mean of 75 and the standard deviation 12. Random sample of size 121 are taken. Find the mean and standard deviation of the sample mean. Again, population has mean 75 and standard deviation 12. Random sample of size 121 are taken. Find the mean and standard deviation of the sample mean. The mean of the sample is still the population mean, which is 75. The sample standard deviation using the formula is 1.09. The third example is a population has mean 28 and standard deviation 22. Find the mean and standard deviation for sample of size 36. In this example, the sample mean is 28 and the standard deviation is 3.67. Now let's move to the real-life applications of the central limit theorem for you to appreciate it. 1. The sample distribution is assumed to be normal when the distribution is unknown or not normally distributed according to central limit theorem. This method assumes that the given population is distributed normally. It helps in data analysis. 2. The sample mean deviation decreases as we increase the samples taken from the population, which helps in estimating the mean of the population more accurately. 3. The sample mean is used in creating a range of values, which likely includes the population mean. 4. The concept of central limit theorem is used in election polls to estimate the percentage of people supporting a particular candidate as confidence intervals. 5. CLT is used in calculating the mean family income in a particular country. 6. It is used in rolling many identical unbiased dice. 7. The probability distribution for total distance covered in a random walk will approach normal distribution. 8. Flipping many coins will result in a normal distribution for the total number of heads or equivalently total number of tails. 9. By looking at the sample distribution, CLT can tell whether the sample belongs to a particular population. 10. It enables us to make conclusions about the sample and population parameters and assists in constructing good machine learning models. So those are the many applications of the central limit theorem. We'll be back for more after this break.
Tayo na sa Radyo Eskwela.
Tayo na!
Taho kayo dyan! Di makatulog sa gabi sa kaiisip, damdamin ko'y mayroong lungkot hanggang sa panaginip. Oh, Berto, di ka ba nakatulog kagabi? Hindi nga ho, Kuya Pekto. Dala ho siguro ng lungkot ng pag-iisa dito sa bahay. Di ho kasi makalabas dahil sa COVID-19. Hay. Berto, may 3 bagay na dapat kang tandaan para maiwasan ng lungkot sa mga ganitong sitwasyon. Una, alamin ang dahilan ng iyong kalungkutan. Pangalawa, maaaring ipabatid ang iyong nararanasan sa mga taong malalapit sa iyo. Nariyan ang internet para makausap mo sila. At ang pangatlo, ilaan mo ang iyong oras sa mga bagay na ikaw ay magiging abala. Hindi lang pisikal na kalusugan ang mahalaga, Berto, pati pang kaisipan rin. Tatandaan ko yan, Kuya Pekto. Maraming salamat sa payo. Isang paalala mula sa kagawaran ng edukasyon at ng himpilang ito.
Now, it's time to check what you have learned through a quiz. In the following questions, choose the letter that corresponds to the correct answer. Number 1. The central limit theorem says that the sampling distribution of the sample mean is approximately normal if A. All possible samples are selected, B. The sample size is large, or C. The standard error of the sampling distribution is small. I repeat, the central limit theorem says that the sampling distribution of the sample mean is approximately normal if A. All possible samples are selected, B. The sample size is large, or C. The standard error of the sampling distribution is small. Number 2. The central limit theorem says that the mean of the sampling distribution of the sample mean is A. Equal to the population mean divided by the square root of the sample size, B. Close to the population mean if sample size is large, or C. Exactly to the population mean. I repeat, the central limit theorem says that the mean of the sampling distribution of the sample mean is A. Equal to the population mean divided by the square root of the sample size, B. Close to the population mean if sample size is large, or C. Exactly to the population mean. Number 3. The central limit theorem says that the standard deviation of the sampling distribution of the sample mean is A. Equal to the population standard deviation divided by the square root of the sample size, B. Close to the population standard deviation if the sample size is large, C. Exactly equal to the standard deviation. I repeat, the central limit theorem says that the standard deviation of the sampling distribution of the sample mean is A. Equal to the population standard deviation divided by the square root of the sample size, B. Close to the population standard deviation if the sample size is large, or C. Exactly equal to the standard deviation. Number 4. Samples of size 25 are selected from a population with mean 40 and standard deviation 7.5. The mean of the sampling distribution of sample mean is A. 7.5, B. 8, or C. 40. I repeat, samples of size 25 are selected from a population with mean 40 and standard deviation 7.5. The mean of the sampling distribution of sample means is A. 7.5, B. 8, or C. 40. Number 5. Which is not true of the mean of the sampling distribution? A. It is the mean of the statistic for all of the samples in the distribution. B. It is the same as the population parameter. Or C. It depends on the sample size. I repeat, which is not true of the mean of the sampling distribution? A. It is the mean of the statistic for all of the samples in the distribution. B. It is the same as the population parameter. Or C. It depends on the sample size. I hope you answered correctly. Answers of the quiz will be revealed next episode. My dear senior high school students, just a reminder and a food for thought. There are 3 C's in life: choice, chance, change. You must make the choice to take the chance if you want anything in life to change. So, start making choices now and make the choices that your future self will thank you for. We are done with our central limit theorem episode. If you still have questions and clarifications, you are free to contact your teacher via text, email, or Facebook Messenger. Please don't forget to submit your learning activity sheet on the scheduled time at the drop box intended in your area. Together, we can make it in our struggle for a quality instructional delivery under the new normal. Have a great day! I am Teacher Diana. Stay safe and God bless everyone.
Patuloy ang edukasyon para sa ating henerasyon.
Sa daan ng pagkatuto ay walang may iwan.
Kaya halina sa Radyo Eskwela!